Excellencies, distinguished and honorable guests, ladies and gentlemen, welcome to this session on planetary boundaries, human development within planetary boundaries. My name is Marcus Oman. I will be your moderator during this session. I'm an associate professor at Stockholm Resilience Center. This about planetary boundaries is, of course, a very important question to discuss. And the same day I was asked if I could be the moderator for this session, I went home and had dinner with my kids. And I asked my 10-year-old son, what do you think about planetary boundaries? And he said, well, Dad, thought for a while, and he said, well, Dad, that's very important. You know, the planet has boundaries, we have our resources, we have our species, and we really have to take care of it. I mean, I'm the next generation, you have to understand that, Dad. And he went on with oil and talked about renewables, and I was really impressed. And after a while I said to him, Eric, I think you should come here and be the moderator for this session. Then I turned to my 5-year-old daughter, Sophie, and I said, what do you think? Well, we were eating chicken. And she looked at her plate and she said, Dad, I love chicken. And there's millions of chicken, so no problem. So they very much expressed two extremes when it comes to planetary boundaries. And we will have a panel here with 6 distinguished participants. I don't think they have those extreme views, but they may represent different perspectives on planetary boundaries. Some of them are still in a session before, which is going on right now. I will present the whole panel when it's here. But I will start with the host for this meeting. It's Stockholm Resilience Center that's organizing this meeting. And Professor Johan Rockström is from Stockholm Resilience Center. He's the executive director. He was the former executive director of Stockholm Environmental Institute. Johan Rockström is a leading researcher and scientist on global water resources with more than 100 research publications. He serves on a number of scientific committees and boards and written several books, including Human Quest, which is on the picture there on the roll-up. I think he will tell you even more of his work on resilience and planetary boundaries now, because Professor Johan Rockström is going to have the opening statement. So please, Johan.
Thanks, Marcus, and warmly welcome everyone. It's wonderful to see you. I know the competition on all your time during these intense days here in Jeju. What I'll try to do is essentially two things. One is I'll actually spend 15 minutes to give you an update on the science on planetary boundaries, and the reason to do that is to really have an enriched discussion and get your help in informing how we proceed from here. But the second objective is really to do that in the context of this Congress, because I really want to start by emphasizing that this science on planetary boundaries is not a sudden leap change in insight from a vacuum. It is 30 years, if not 50 years, of empirical, intellectual advancements of our understanding of how the planet operates, the human interaction with the planet, and why we need a fundamental new paradigm. It is such a dramatic message from science. It totally changes the entire development paradigm. It does exactly what Peter Backer pointed out yesterday evening. It leads to a revolution. It leads to a transformative thinking of our economy, of our institutions, and our behaviors. That's why, for example, it was a central theme of Rio Plus 20. It was even in the texts in Rio Plus 20 all the way to the end. But then it was felt to be too threatening to the US and to some of the poorest countries in the world that don't trust the North to truly share the remaining ecological space on the planet. So it turned out from originally being from science to science to have become a concept that really, to say, vibrates in different communities, from IUCN and the entire civil society, in governance, in business, and very much in the broader communities and societies. So we've been, as scientists, quite thrilled, but also shocked over the resonance it's had worldwide. And that's why we are now at a stage where we really need some input from you, because we're at a formative stage of taking the next steps, and I'll share with you where we're going. So many of you might have heard part of this story, you might have read of it sometimes, but I'll still go through this sort of say quick ABC of how we came to this concept, what's the empirical basis behind it, but then give you some of the latest updates of where we are and the critique that has come and how we're advancing things, and then just share with you some thoughts on the way forward. And it all starts here. It starts with Will Steffen, Paul Crutzen, and John McNeill. John McNeill, one of the fathers behind the whole concept of sustainable development. Paul Crutzen, the Nobel laureate, that was one of the three identifying the depletion of the ozone layer. Will Steffen, one of the leading global environmental change scientists, in 2002 publishes this paper saying that the evidence now shows we've entered a new geological epoch, the Anthropocene. I'll just place that back very briefly. And this is based on empirical evidence that we have now become a geological force. We, 7 billion people, multiplied by the industrial metabolism and our consumption patterns, are the largest factor of change at the planetary scale. Now, science, just slightly later, if I can just get this, okay, let's do it that way. In October 2011, published a whole special issue, which I really recommend to you, showing the evidence behind the Anthropocene. And that evidence arises from the timelines from the Industrial Revolution and the exponential growth of human pressures on the Earth system. It's the 80% overfishing of fish stocks in the upper left-hand corner. It's the rapid acidification of our oceans, potentially leading to collapse and anoxic events. It's the exponential curves of carbon dioxide and population growth. And they're all based on empirical evidence. And this is kind of a game changer in terms of the pressures of humanity on planet Earth. It means that we can start talking of humanity having entered what I've called a 369 world. It's a world that is close to being committed to 3 degrees warming. And remember that we have an envelope over the last 12,000 years of plus minus 1 degree. So we are committing ourselves potentially to catastrophic outcomes on climate. The 6 is that we are in the 6th mass extinction of species on planet Earth, the first to be caused by humans. And we're more or less committed to 9 billion people. So this is the world we're facing, the 369 world of climate change, biodiversity loss, and human pressures. So that was one starting point to this journey. This has, as you know, been articulated increasingly strongly from science. And this is just a catalog of some of the latest synthesis from science, from the Nobel Laureate Symposia on Global Sustainability, all the way to the Blue Planet Prize synthesis. If you haven't seen this, I really advise to have a look at this phenomenal synthesis from all the Blue Prize laureates, led by Bob Watson, on the summary of science. And what comes out from these documents is, in my mind, the first time science articulates the heading up at the top: humanity has reached a planetary saturation point. Now, this is not something that has been said before. It's not something we've known before. It's recent scientific evidence showing that we can now have empirical evidence that we're hitting the ceiling of the hardwired biophysical processes on the planet, beyond which we can expect surprise and abrupt change. And this means, and that is a statement in this Blue Prize Award, that the human ability to do has vastly outstripped our ability to understand. And this is one of those fundamentals that we are simply propelling ourselves with one paradigm without considering what we're doing to the natural capital in the biosphere. That resilience matters, and I'll come back to that, meaning that we simply have to now understand that we have to keep the biosphere and the planet strong in the face of stress and change. Our definition of resilience here, by the way, is in 3 parts. One is the fundamental capacity of any system, a social or ecological system, be it a wetland or a forest or a lake or the planet, to withstand shocks and disturbances while still remaining, persisting in a desired state. So it's the ability to take a punch without falling. But the second component of resilience is the ability to adapt to change. What are the components in a society, in a landscape, in a marine system, when things change, to adapt so you don't fall out of your desired state? And the third important component of resilience is what are the abilities of natural and ecological systems and societies to transform in the face of crisis. So if a system tips over, be it a society or an ecosystem, what's the ability to rise in a new trajectory? That's resilience. Persistency, adaptability, transformability. Okay, how has this been taken up in policy? Well, the reason why it's so important to have this discussion together today is that even Ban Ki-moon in the high-level panel on global sustainability writes a report to the Rio+20, the equivalent of the Brundtland Commission, called Resilient People, Resilient Planet, which for the first time states two things. One is that our current development model is unsustainable. We've come to the end of the road with our current paradigm. We simply have to come to the insight that now we need a transformational change. And secondly, it is the first time, I think, that high-level policymakers absorb the notion that we may be facing catastrophic tipping points, and that planetary boundaries is something we need to respect. This is in this report put on the table for world leaders at Rio+20. That's a totally different definition of sustainable development as compared to the Brundtland Commission in 1992, which after all still articulates sustainable development very much in terms of minimizing environmental impacts and trying to sustain systems at the local to regional scale. It didn't have the notion of the threat to the stability of the planet at a whole. Has this been understood by business? Well, until recently, no. This is normally how we portray shocks in the world. This is the Lehman Brothers vortex and the financial crisis 2008. But as you may recall, even The Economist invites humanity to the Anthropocene in 2011. So there's something happening here with an understanding beyond science. And The Economist, as you know, is a British weekly, and they have a wonderful, typical British upper lip understatement to summarize the feeling of science in this issue, which I'd like to cite to you, which is, when reality is changing faster than theory suggests it should, a certain amount of nervousness is a reasonable response. But this is, in one sentence, where science is today. In fact, in area after area, real world is changing faster than theory stipulates it should. When it comes to extreme events and the record droughts in the US, it goes beyond what science expected. In fact, 2 weeks back, Jim Hansen, one of the co-authors of the Planetary Boundary Research, published a very seminal paper showing that what was extreme weather, you know, the +3 standard deviation weather in 1955, is in 2012 normal weather. 5 years back, the worst case scenarios for that was that that could happen in 2050, 2060, 2070. So what was projected almost as science fiction in terms of how we think in quarterly, 2-3 year perspectives is happening much faster. The Arctic in 2012 may have gone into its death spiral. It's a bottom observation again in terms of lack of summer ice. And there's a possibility that 2012 will be seen in 10 years' time as the most important year in the modern history of humanity, because it may be the first time the planet sends humanity an invoice. Because so far the planet has been very forgiving, but the Arctic tipping point may be the first invoice to humanity, and I'll explain a bit more why. But these are the evidence why planetary boundaries matter. And the reason why the Arctic is such a good red flag for us to react on, and why it matters for the planetary boundary analysis, is that it has feedbacks. And that is one of the key elements of understanding the concept of planetary boundaries, which is, it's not only about understanding the pressures, it's about recognizing where are thresholds beyond which we may have regime shifts or tipping points. But the only way for a tipping point to occur is if there's a feedback that reinforces a new undesired state. And the most well-known feedback, the most pedagogic understood one, is this one. This is how we'd like the Arctic to look like, a white surface that reflects incoming solar radiation. But in 2007, 30% of the summer ice disappears in 2 months. Now, what happens is it changes color. That's the feedback. The system turns darker and it self-warms by absorbing incoming solar radiation. So as soon as a feedback is identified, science clicks on the nervous button, because this means that the system can actually tip and reinforce an undesired state and get locked there. That's the whole theory of resilience. Systems have multiple stable states if there's a feedback, and the feedback is required. If there's no feedback, the system can go down, but then can go up again in a linear fashion. In 2007, this was perceived as potentially just a freak outlier. 2012 is a recognition that it may not be so, and that may mean that it is self-propelling itself to a state of no ice. If that occurs, it will affect weather patterns in the northern hemisphere, and it will warm the planet with probably at least another ½ degree, because it's a cooling chapeau. It's the air conditioner, it's the cooling system for the planet to have a white hat at the top of our wonderful planet. So this is what we're looking for when we're trying to combine the analysis of planetary boundaries. We see the same behavior on coral reefs. This is how we want them to look like. And then we eutrify, we warm, we overfish, and the systems, with a trigger such as an El Nino event, can flip over. The feedback is known because soft corals take over, it gets logged. And we have a whole catalog of these type of tipping points. In fact, the Resilience Center today is a repository of the world's regime shifts database, and I'm sorry to say, it's a very long database. Very long database. This is rainforest that can tip to savanna. This is savannas that tips to desert. These are lakes that tip from desired diversity-rich, oxygen-rich systems to anoxic systems. This is our home, the Baltic Sea, which probably tipped in 1989, linked to biodiversity, because eutrophication and warming connected with loss of cod, the top predator, led to explosion of herring. Herring ate up all the grazers, the animal plankton, which meant that algae exploded. When they die, they consume all the oxygen, and the system gets anoxic. These kind of dynamics with biodiversity, global warming, environmental change, lead to tipping points, is at the heart of the understanding why we need a new definition of global sustainability. So we asked them the question, what happens when you combine these two insights? So just to summarize, what I've so to say, launched on you now is one set of evidence of the Anthropocene, which is essentially the pressure that we are in this exponential growth of pressure on the planet, the exponential hockey stick curves. But you need to combine that with resilience theory, the insights that we can push systems across catastrophic tipping points. We need to understand feedbacks, and that the systems are strong to a certain point. Now, if you combine these two, we recognize that, well, do we for the first time have to put the planet into this kind of analogy that we normally use with our students, where we say that a desired state is here, an undesired state is here, there's a threshold, and we've normally always put an ecosystem here, illustrated by a ball. And when resilience is lost, the cup gets more shallow, the system can easier tip over. Now we ask, in 2007, do we have to put the planet there? And are we threatening the stability of the planet and its ability to support our modern world? To answer this question, we need to know what is our desired state. And interestingly, there's a lot of data to define a desired state, and the best one is ice core data. This is from Greenland. And normally we look at the 1 million year trajectories, you know, and the 200,000 years in and out of glacial and interglacials. This is perhaps the most relevant period, it's the last 100,000 years. It's relevant because we've been modern humans during this entire period. We've had the same intellectual and physical ability to develop civilizations as we know it. This is temperature variability, showing a good proxy of how it was to live on Earth. And as you all know, it was a jumpy ride for humanity indeed. For most of this part, we're hunters and gatherers. We're 2 to 40 million people. You may have seen Stephen Oppenheimer's fantastic work in this cold point here. This is a cold point where most fresh water is tied up as ice in the poles. And we have such difficulty in feeding ourselves that we're probably down to 15,000 fertile adults. 15,000. We're virtually extinct. We live in the highlands of Ethiopia, and we're pushed out of Africa due to water scarcity, food scarcity. And then we enter the Eden's Garden, the Holocene, and we barely enter this period which has a perfectly stable climate, predictable hydrology, all the ecosystems settle into the biomes as we know them today. IUCN would not be able to do its red list if it hadn't been for the stability of the biomes in the Holocene. We invent agriculture, and off we go on this civilizational journey. We know also well, we're 3 billion people in the mid-1950s, and that's where the acceleration point starts. And we're 7 today, committed to 9. So our starting point of the planetary boundary research was to say, the Holocene is the only state we know that can support the modern world. That might seem like an obvious statement, but I tell you from science, it's so to say brand new. It's simple, it's clear, and I would argue it has little uncertainty, but it is very powerful because we know the Holocene so well. We know it scientifically so well. We know it for temperature, for carbon, for phosphorus, for freshwater, etc., for biodiversity. And therefore we took that as our reference point when we then analyzed and tried to identify planetary boundaries. This is just to show that this is data from Antarctica, showing the same extraordinary stability for the Holocene. So we know very well that the Holocene is extremely stable. And that then led to the question, and the planetary boundary question is very simple. We ask science, what are the processes that we then have to be stewards of to have a planet that remains in Holocene-like conditions to support the modern world? what do we need to cater for to avoid propelling ourselves out of the Holocene stability now that we're entering the Anthropocene where we're pushing so much pressure? And then we ask the question, if we can identify these environmental processes, for each one of those, can we find a control variable, a good indicator of change, which regulates the point at which a system can abruptly change? And can we, for each of those control variables, identify the point of a threshold from science? And the difficulty, as you all know, is to identify the exact point of a threshold. In fact, it's virtually impossible. Science doesn't understand the Earth system well enough. So we said, let's at least find a standard deviation, the scientific uncertainty around the threshold. And then we took the only normative stance in this concept to say we should reasonably apply the precautionary principle, so we put the boundary at the lower end of the standard deviation. So we applied the theory of planetary boundaries exactly as we deal with our own body temperature. 42 degrees Celsius is our tipping point. We go from a desired state, living, to an undesired state, dead. That's a very clear tipping point. But we never manage ourselves against the tipping point. We manage ourselves against the boundary, most of us at around 38 degrees Celsius. So the 38 degrees Celsius is the equivalent of the Earth's planetary boundary, while the tipping point is the place where things can